notice, and this is the typical copyright. We continue with mathematics syllabus for C-Sec 2018 to 2027. Schedule of videos. Section 1, Number Theory and Computation. All 33 of those videos have been published on YouTube as of October 14th, 2024. Right now, I am working on these 12 videos from Section 2, Consumer Arithmetic, and hopefully should have those ready by the 31st of October 2024. Then November 2024, sets. December 2024, measurements. January 2025, statistics. February 2025, algebra. March 2025, relations, functions, and graphs. April 2025, geometry and trigonometry. And finally, by May 2025, mid-May, hopefully, vectors and matrices. And that will cover all the objectives in this syllabus in 1 year. As I have pointed out previously, and I keep repeating this, I have divided section 1 into 33 videos, all of which have been made available on YouTube in their entirety, not just part of a video, but the whole videos. This section forms the foundation on which the rest of the syllabus is based. So it is important that you look at these 33 videos and know them very well in order to continue with the rest of the syllabus. Just a reminder, you need to know the times tables 2 to 12, as calculators are not allowed to be used in paper 1. We are now here, objective 7, compound interest, and video 7 in this section. We will have to go up to video 12 because I have divided objective 10 in 3 parts. Now keep in mind that not all of these videos will be available on YouTube in their entirety. This one, compound interest, is available in its entirety, the whole video. So we completed those 3, and these 3 more, that would be 6. Now we are at objective 7, solve problems involving compound interest. And we have some explanatory notes. Formulae may be used in computing compound interest, and also the use of calculators is encouraged. And we still have to do up to objective 10, and this objective 10 is divided into 3 videos, as I said. So those 9 objectives, 1 video each, and then objective 10, 3 more videos, and that would give us 12 videos for this section. Solve problems involving compound interest. Recall the last video on objective 6, we were dealing with simple interest. And now we are here, so we could block out that part. We finish with it. We already learned in the last video what principal is, what the time is. It is in years. The rate is the percentage, annual percentage. The amount is the principal plus the total interest at the end of the agreed upon period. So compound interest is the interest calculated on the principal and the interest accumulated over the previous period. It is different from simple interest, In simple interest, we were calculating the interest only on the principal. So how does compound interest work? The interest from a previous period is added to the previous principal to become the new principal for the next period. So let us say if somebody invested $2,000 at 8% per annum, that means per year, for 8 years. If we work that out on the simple interest, notice what happens. Every year, year one, the interest is $160. Year two, you use this same principal and you get $160. Yes, over the 2 years, you now have this amount of interest. And then year three, again, the principal of $2,000 is used. You get another $160 for the third year, and so on. That is simple interest. Now, for compound interest, things operate slightly differently. At the end of the first year, you do get $160. But instead of that $160 just being there, nobody's using it, that $160 is added to this original principal. And for the second year, you now have a new principal, which is $2,160. So now the interest, 8%, is calculated on this new principal, and you get $172.80 for interest for the second year. This $172 is now added to that 2,160 to give us $2,332.80, and so on. So notice that this interest keeps increasing all the time because this principal that you have here keeps increasing as you added the previous interest to make up the new principal. Notice over here, if you are dealing with simple interest, your total interest will be $1,280. Whereas if you do the same setup, but this time compound interest calculated annually, you have $1,701.86. So you have some more money. So let's look a little more detail in this, just in case you didn't get it the first time. $2,000 at 8%, year one, you get $160. That $160 is added to this $2,000 to become the new principal here. So year two, you are beginning with a principal of $2,160, not $2,000. And then you calculate interest on this new principal, and you get $172.80. And then this $172.80 is added to this principal here, and the new principal for the third year is $2,332.80. 8% of that will give you this. You take this interest added to this number here, and you get the new principal for the fourth year, and so on. Now you can actually do this on a table like this, but later on we will learn of a formula to do the same work. So the objective says solve problems involving compound interest. So we are not going to use a formula here. We will use a table and calculate each interest and amount individually. So Mrs. Backus deposited $20,000 in a fixed deposit for 3 years at 8% interest per annum to be calculated quarterly. How much money will she get at the end of the 3 years? In other words, for $20,000 plus interest, how much will that be? As I said, there is a formula which we will learn about later, but for now, we will go and do this using a table, step by step. So let's set up a table like this. Year one, quarter one, she deposits $20,000 at the end of that quarter. Now, since it's 8% annually, it will be 2% quarterly, and we are calculating this quarterly. So we multiply the 20,000 by 0.02, and we get $400. That's her interest at the end of the first quarter. Now for the second quarter, that interest will be added to this principal, and we begin with $2,400. We multiply that by 0.02 for the next quarter, and we get $408. That's the interest at the end of the second quarter in year one. That will be added to this, and we get the new principal down here for the third quarter. Calculate 2%, which is 0.02, and we get this amount of interest for the third quarter. Add that to this to get the principal at the beginning of the fourth quarter. Calculate your interest on this, so multiply it by 0.02, which is 2%, and you get this interest. So at the end of the first year, Mrs. Bacchus has this amount here, plus this one interest here. Those other interests have already been taken care of when they were added to the initial deposit. So beginning year two, quarter one, you know how this works now. This interest on the right here is added to that principal. You get a new principal beginning year two, quarter one, and the interest, and so on. Without the formula, this is what you would have to do. So finally, at the end of year three, quarter four, this is the principal now. Remember, she started out with 20,000. This is the principal now, and this is the interest for the last quarter. So if we add those two, our amount will be $25,364.84. In total, this is the amount of interest she got. But these interests have already been taken care of in this number here. So the question says, how much money will she get at the end of 3 years? Our answer is this, $25,364.84. So as I said, the interests have already been taken care of in this amount. So we already looked at this question, and the interest was compounded quarterly. This is what we came up with, that she would get $25,364.84 amount, total amount, compounded quarterly. Now, if it were calculated annually, at the end of the first year, that would be $1,600, second and third year. And so she would get $25,194.24. It's just a matter that this one on the left here, the interest was calculated quarterly, compounded. Over here, it was annually, and yes, it was still compound interest. Since it's annually, you multiply by the full 8%. Over here, we were multiplying by 2% because it was calculated quarterly. The interest here is $5,364.84. Over here, it's $5,194. Same money, same bank, same interest, same amount of time, except the one on the left, the calculations were done on compound interest quarterly, 4 times a year, as opposed to this one on the right, once a year at the end of the year. Now, if you find this video useful and are interesting, please like and share. Like and share. You may also consider subscribing to this channel. Now, the formulae that we are looking at are these. Amount is equal to principal multiplied by 1 plus r over n, close bracket, to the n times t power. And I will explain what these are as we actually come to use these formulae. So that one was for amount, and this one was for compound interest. The truth of the matter is, if you can calculate the amount, you just need to subtract the principal from the amount to get the compound interest. So you really don't need both of those. However, I will teach you how to use both of them. Now, I did say that you will be given a formula sheet for all three papers. Paper 1, paper 2, and paper 3. But this is the formula sheet you see here. And note, there is nothing like these formulae that you see on the right. So these formulae are not included in that formula sheet. Compound interest formulae are not on the formula sheet. If you look at the formula sheet closely, this is the top half, and this is the below half of that formula sheet. No compound interest, no amount when calculating compound interest. So, my advice is to learn the first one, this one here, and the second one is actually a variation of that first one. I will explain that in a little while. But I strongly suspect that if you have to use this formula, either one, in a question, that CXC will provide that at the end of the question. But to be on the safe side, learn this first one. You don't have to learn both of them. Make sure, though, that you know how to use both of them if you see them. So now we will consider the two relevant formulae. You were just introduced to them. Let's look at them closer now. For compound interest only. Now this one will calculate only the compound interest. Compound interest is equal to principal multiplied by 1 plus r over 100n, close bracket, to n times t power. And then you still have to minus the principal. That's for the compound interest. That's just the interest. P stands, of course, for principal. R, uppercase R, is annual interest rate in percentage. Uppercase, see, uppercase R, that's the annual interest rate in percent. Now, if you see a lowercase r, which we will see just now, that is the annual rate as decimal. T is total time in years, and N is the number of times interest gets compounded each year. For amount, remember, amount is the interest plus the principal. P multiplied by 1 plus lowercase r over n, close bracket, to the n times t power. Actually, as I said, that formula for compound interest is a variation of this one. And I will explain that as we go along. Let's look again at Mrs. Backus and her deposit of $20,000 fixed deposit for 3 years at 8% interest per annum. We calculated that and we said that the amount she will get is this amount. And this will be the compound interest. Now, if you can calculate the amount, you will just subtract the initial deposit and you will get the interest. So if you are going to learn any of these formulae, learn the one with amount. So 25,364.84, that is the amount she will get. Now we are going to do that, but this time we will do it with the compound interest formula. And this one over here is for the amount. We will deal with that after we finish with compound interest. So compound interest is equal to the principal, which is 20,000, multiply by 1 plus R, which is 8% annual interest in percentage, over 100 times N. Since it is to be calculated quarterly, N will be 4 times per year, close bracket, and then this index here will be 4 times 3. How many times it is to be calculated per year and how many years. And after you do all of that, you will subtract the principal. So 20,000 multiplied by, when you work out this piece in the bracket here, you get 1.02, and that will be to the 12th power minus the principal, and you get this amount minus the principal. As I said, this actually is the amount, and we now subtract the principal, and so the interest, the compound interest, is $5,364.84. So let's go and calculate the amount now. Amount is equal to principal times 1 plus R. Now, this R here is the rate of interest as a decimal over 4 multiplied by 4 times 3. And so we get 20,000 multiplied by this factor here, 102 to the 12th power. And we get the amount here, which is actually that same amount there. And now we will subtract the principal to get the interest. Because you carry this R over 100 to a decimal, use a lowercase r and you use a decimal instead. So you don't have percentage up here and you get rid of that 100 down there. Other than that, it is the same formula. And you didn't need to subtract the principal on this end because you are calculating the amount. Okay, so this was when we calculated it. This table started at year 1, quarter 4. As a matter of fact, from there, so now we're at year 2, quarter 1. So this is only part of the table. The same table that we saw before, 25,364.84, that is the amount. If you subtract the principal from that, which is this, you will get the interest, which is this. But if you learn the formula for amount, you don't need to learn the formula for compound interest. 5 years, 8%. So compound interest, 20. Now, it's calculated quarterly. %8 over 100. And so you get 20,000 multiplied by this part here to the 20th power. That would actually give you the amount, and then you subtract the principal to get the compound interest. And that is the amount minus the principal, and you get the compound interest is $9,718.95. Now, if you calculate the amount, we already know that we will get this. So it's 20,000 multiplied by 1 plus. Now, remember, we reduce this 8% over 100 to decimal, so that will be 0.08. N, of course, is 4, calculated 4 times per year, close bracket, which is number of times calculated per year times the amount of years. And so you work that out. This part in here works out to be 1.02. You carry that to the 20th power and then multiply by 20,000 and you get 29,718.95. That's the amount, which is this same thing that we got over here, and then we subtract the principal to get the interest. So as I said, if you are going to learn one of these, learn this one. It's easier to learn, easier to use, and if you get the amount, you could always subtract the principal to get the interest. All right, so Mrs. Bacchus deposited $20,000 in a fixed deposit for 10 years at 8% interest to be calculated quarterly. So I'm not going to show you the actual calculation. On a spreadsheet, this is what it works out to. 20,000 compounded quarterly at 8% for 10 years. So on the right here, you have the interest. And on the left here, you have the increasing principal because the interest is added to the principal to give you the principal for the following year. If you plot all of that on a graph, you get a graph that looks like this. It's exponential increase. This is compound interest. If you were to do the simple interest, it would look like this blue line here. So as time goes by, notice the difference from here to here and the difference from here to here. As time goes by, that difference becomes greater on the compound interest as opposed to the direct simple interest. Now, Mr. Patel invested $50,000 for 4 years with an annual return of 6%. If the interest is compounded semi-annually, calculate the amount at the end of this time period and also the total interest. Now, this is kind of redundant because if you know the amount, you just subtract the $50,000 from it and you will get the interest. So let's calculate the amount. Amount is equal to principal, which is 50,000, multiplied by 1 plus, now remember this R is this rate as a decimal, so 6% as a decimal is 0.06 over N. It's calculated semi-annually, so that would be twice per year. And that would be 2 times 2 times 4 years. And so 50,000 multiplied by this piece here in here works out to be 1.03. And then we will carry that to the 8th power. So it's 50,000 multiplied by this amount. Now that is the factor by which it will increase. So the $50,000 will become 1.26677 times the 50,000. And you get $63,338.50. That is the amount that he would get. That includes the interest plus his initial $50,000 investment. Well, if you want to find the interest, you would just obviously subtract from that the investment, and he earned $13,338.50. Next question, example 4. Mr. Adams invested $70,000 for 10 years with an annual returns of 7%. If the interest is compounded annually, once per year, calculate the amount at the end of this time and also the interest. Amount is equal to principal multiplied by 1 plus the rate as a decimal. So 7% is 0.07 over 1 because it is calculated once per year, multiply by 1 times 10 years. And so that would be 70,000 multiplied by this part here, works out to be 1.07. And now you have that to the 10th power. This part here would be 1.96715. So his money would increase that amount of times, almost 2 times, which gives us $137,700.60. So that is the amount he would get if he invested 70,000 over a 10-year time at 7% per annum, calculated annually. Of course, if you want to know the interest, you just subtract his initial investment from the amount, and he gets $67,700.60 when the interest is calculated annually based on compound interest system. So, how much more would Mr. Adams have gotten if the interest were compounded monthly? If the interest were compounded monthly, instead of 1 here, you would have to get 12. Instead of 1 there, that will be 12. And this will change. That will become 120. And this factor will be different. You can do it yourself and see what you get. But essentially, this is what you have to do. When you work out this factor, it would be 2.00966614. You multiply that by the principal, that will give you the amount. From that amount, you subtract the principal, that will give you the interest, and then you subtract this interest because the question says how much more if it were calculated monthly. And so this is the interest he would have earned calculated annually. So when you calculate it, the difference you get is $2,975.70 when the interest is compounded on a monthly basis. Example 5, Miss Jones wants to know how much money she should invest in order for the amount to be 50,000 if the returns are 9% per annum compounded monthly for 10 years. Now, this is different from what we were doing. Previously, we were calculating amount given the other things. And from that, we could easily calculate the compound interest. But now, we want to know the principal and given the rest of the stuff. So she wants $50,000 at the end of 10 years if the interest is 9% per annum and it is calculated monthly. Okay, that is not as difficult as it looks if you understood everything we have done so far. So we change the subject of the formula and leave P alone on this side, which would be equal to A. And this rest of the stuff here, everything there goes underneath if we cross multiply. So this is the formula now that we have to calculate the principal. How much money should she invest under those conditions to get $50,000 at the end? So we will substitute the numbers we are given, 50,000 over 1 plus, remember this R is the rate as a decimal, 0.09 over n, which would be 12, close bracket, So that would be 12 times 10 years. So that would be 50,000 over. Now, all of this, all of that work out to be 2.451357. So the principal, the amount that she need to invest would be $20,396.86. Now, is that right? We can verify our answer. And in the next slide, we will reverse engineer this answer we got up here to see if it is correct. So now, if she were to deposit $20,396.86, under these conditions, will she get $50,000 at the end? So now the principal is that 0.09 over 12 to the 12 times 10 power, which is this piece in here works out to be that 120th power. When you work this piece out, let's see what the factor will be. 2.451357. Remember, that was the number we divided by when we were trying to find the principal. Now we are multiplying this to find the amount. 49,999.99, almost down to the last cent. So we know we were correct. She is going to get her $50,000 at the end of 10 years if our interest is compounded monthly at 9% per annum. And that should suffice for this objective. It's a video, so you could always go back and look at it again if you don't understand anything. So we just looked at objective 7 in section 2. Solve problems involving compound interest. Now, CXC could be funny. Use of calculators is encouraged. You think? You think you could have done any of the stuff we did in this video without a calculator? Yes. What an understatement. And that brings us to the end of this objective 7 in section 2.